going to share screen. Okay. Admit all. One more. Just remind me in case when I'm in the session. Okay, here there's a chat question. Let me see. Getting on the call. Can you enable the links? You mean enable? Okay, I will see. Okay, what the problem is. Sarah, sure. Enable the link. Okay. Next, I'm going to start sharing screen. Okay, so yesterday, not yesterday, it's Tuesday, okay? So Tuesday, we started about the LinkedList. That's we discussed with a comparable interface, okay? And I remember we already started with the second example. So implemented the LinkedList with iterable interface, okay? And the iterable interface has one abstract method. Who still remember what that abstract method is for iterable interface?
Iterator.
Yeah, very good. Iterator, okay. And for this linked list, the node class is the same as the previous discussion. We have two parts, data part and next part, okay. And then the insert or remove, nothing new, contain. And okay, so then let's come back to the contain method. For the contain instance method, here we do for each loop. Is it why we can do for each loop here? Who still remembers? Why we can do for each loop here? Within
because we implemented iterable interface.
Yeah, because our linked list is it implement iterable interface. Okay, that's why you can do this for each loop. Otherwise, you cannot. Okay, so keep this in mind. And then next, let's see. Okay, so this is the key part for iterable interface. Because this linked list, we defined implement iterable interface, so you need to implement this iterator method, okay? Iterator method returns what? Returns an iterator. An iterator is also an interface. Be careful. Interface, okay? And what here it tries to do is quite simple. It just return some new linked list iterator, okay? So then let's see. Here, we define this linked list iterator. So this is an inner class. Okay, because this class is defined within the linked list class, okay? And this class, it implements this iterator interface, okay? And the iterator interface, it has three methods you need to override. It has the has next method, and the remove method. Okay, so because this class, then it's also a concrete class. Because it's concrete class, so you need to implement all three abstract methods in the iterator interface. Okay, you need to implement all of that. So then let's see what this class does. So for this class, it has one instance variable. We call it next node, and the type is node. Okay, it's node. And the constructor. So constructor just get its instance variable, the next node, set it to our linked list first node. Is it? Because over here, the iteration, so you're going to do node by node visit, basically, in this case, for the iteration, is it? So the iteration is based on node. Is it based on node? So that's why a node in linked list. So because of this requirement, is it? So we needed to associate this instance variable, is it? Associated with the first node in linked list. That's why I just set it to the first node. That's what the constructor does, okay, for this. So then did you see, once you do this, return new linked list iterator. So basically what you will get, okay, you will have the next node set its footprint to the first node on the linked list. Is it on the linked list? That's what it does. Okay. And then let's see. Let's see. So then we have this has next method. So in the has next is try to check. Is it? So here is your linked list.
Yeah.
Your linked list, is it? So here is the first, first node, is it? And now you have this next node set its footprint also to first, is it? And this has next want to check if it still has the next node, or is it the last node? Is it? When you reach the now, that means you already reached the end of the linked list. Is it? So that's what this has next going to check. Just check if it reaches the end of the linked list. And then next, let's see. This next method. This next method, so over here, we have our linked list. Then we have the linked list. So we have this next node. The next node start at the first node, is it? So it will, so here are some information. It is supposed to be E1, E2, E3, anyway, some objects, is it En, okay? And what is this next? Return type is T, is it? So the T consistent with the data part. Data part of node, of the node, is it? So node, you have two parts. So this is T something, is it? And here is the next. Is it? So this is, so it's the type, it's just to try to get the contents of the node, is it? And of course, first we are going to check if you reach the end of the linked list. Is it? If it is such a case, then it says throw the exception, is it? Otherwise, you are going to get whatever the current. So the iterator landed at the current node. Okay, it's the current footprint. You get the current footprint with the dot dash. Then you advance. So after you get the current iterator's footprints contents, then you advance to next node. Is it? And you return what? Return whatever the current. Okay, be careful. Okay, not to the next node, the current visiting node. Okay, that's what this next does. Okay, and we are also, you also need to implement the remove. So remove is just whatever you currently landed, then you just remove the current node, is it? And over here, I didn't implement, okay? I just do throw some exception, okay? Okay, so that's regarding this version of the linked list. And be careful, okay, this linked list, we implement as what? As a generic one. This is a generic one, is it? And it's bounded. Okay, bounded by what? By that interface, the extent, okay? So we understand this linked list. Oh, let me get to the driver part. Okay, so now we got to the driver part. The driver part, let's see. So we first create our linked list. But this time we are going to create the type is our car, the car that we just defined. Is it? So you do new, you invoke the constructor. And we can leave this blank, okay, because it already know the type is going to be car. And then because we're going to insert every car, so you need to have car object created. Is it? So that's why here we create the first car, we call default. Is it? Then we insert it. Is it? And at this point, the first node is the first node. Is it? And then we keep calling insert after. Is it? After the first one. Is it? So that's what we did. Okay. And then we want to output all of the linked list, the cars. Is it? So that's what this part does. Okay, and then next. Next, we call our linked list that copy list. Okay, be careful, this copy list does deep copy. Okay, does deep copy. And then we check if both have same content. Okay, both have same content here. And then what next is try to check, okay, call that contains to check if this specific car, as it is in the linked list. If it is, then you do the remove, okay, do the remove. But let's get back, because over here you see, I create a new, that car 4 black, is it? And then let's see, car 4, yeah, it's the same content. Is it kind of like a clone? Okay, then let's get back here. Here, what we do, let's go back here. What do we check? Oh, we check that equals. So what the equals does? Okay, for the equals, what it does is it also check what? Check the content. Content, is it not reference? Not a reference, is it? So in this car, you have, in this case, we have a car, then we have a clone of car, as a clone of car. So then in this case, that will be equal. So that's why if we go back, here, this list of car, it insert after this car, is it car 4? And then over here you say, oh, you check, you still call new, is it car 4? But it will work, is it, because we just care about the content. Both of these two cars, they have same content, is it? So this contains will return true, because it will return true. And if that, then you can remove, that you can remove the code. So that's how this part works. And after remove, you can check if that part get removed, okay? And what next try to show, this is kind of like in array, you have the index operation, you get a specific part, is it? So retrieve item, is it from list, is it from the list? So this is just that retrieving, okay? So also nothing new here. Okay, then next let's see the part that related with iterator, is it? And for iterator here, we are going to demonstrate two use, is it? One is, you see, the for each loop. Okay, because this list of cars is of a linked list, is it? So the type is the linked list that we define. And this linked list implements iterable interface. Because it's implement interface, that's why over here, you can do this for each loop. Okay, for each loop. Okay, and here the concept is it uses that external iterator implicitly. Okay, so basically internally it still runs that has next and next. Okay, next, so that it can do this for each loop. Okay, for each loop. So this simplifies a lot of our work, is it? Okay, with iterator, because we implement the iterable interface, is it? You can also explicitly call its iterator method, is it? And you get this iterator, is it? And the return type is an iterator, is it? And basically this iterator returns what? It returns what we define as linked list iterator, is it? That's an inner class. It's a concrete inner class, is it? And the iterator is an interface. So this the type is an interface defined as iterator, is it? And the iterator method returns a instant, so returns an object. And this object type is what? Is linked list iterator, is it? And that iterator implement iterator interface. That's why you can do this kind of assignment. Okay, this is OOP programming, is it? Dynamic bind, is it? Okay, so that's why this is allowed. Okay, and because it returns that linked list iterator instant, is it? So that's why then you can call this objects has next method and its next method. That's it. So basically over here, what we did is we explicitly use this iterator to do the loop. Is it? And here, the for each loop just simplify the work for us. Okay. And then you may say, why do we still need this? Is it? Later on in our next exam, you will see. Because sometimes if you just use for each loop, you cannot remove. Okay, you cannot do the delete. Once you delete, it's break the definite loop. Okay, definitely. So there is a fixed number of iterations, is it? And if you call remove here, you will change the loop times, is it? Then it won't work. But if we provide our own iterator, okay, our own iterator, you implement has next, and remove, then it won't break the loop. You can, even though after you do remove, you can still do the loop. Okay, so
I have
that's,
a question.
yeah, please.
So is this while loop, so like the first option with iterator, is it faster than for each loop?
Is it faster than the for each? That's a very good question. I haven't investigated this topic. I didn't think about it regarding the speed. That's a good question. Maybe that's that if you find it out and share it with us next class, you get some bonus point. Okay, but that I never thought about this. Yeah, honestly. Yeah, is it going to be faster? I guess it's going to be faster.
And it will be faster because with object X, because for each loop, we copy objects. So I think it
Uh,
takes time.
okay. I haven't, yeah. So I guess because over here you directly call off the method itself, and over here internally it has some other mechanism needed to deal with the for each loop. That's just my instinct. Okay, yeah. So what you said is because for each loop needed to do copy the item. Is it 2x? Is it?
Yeah.
That's what, yeah, because, yeah, that's, I think that's makes sense. Oh, hold on, let's get to this. Yeah, because next, what next it returns the object. Is it return object? And here you have this X. Is it? You have this object X, and then it's kind of you get that object. So that's some more operation versus over here you directly get the object. Yeah, that may be true. Okay, but let's find out. Okay, so that's the second example. Any more questions regarding second example? If not, we will move to the last one. The last one is more complicated, okay? So if you take a look, the third one, over here we have three files. We have my list, and then my linked list, and then the driver, okay? So let's take a look. First, my list, what does that mean? Okay, so here I gradually add the complexity. So this example, the purpose is try to mimic what Java did, okay, for the linked list. Because if you recall for collection, is it for collection? So so you have iterable, the top interface, is it? Then we have collection, interface. Under it, there are 3 branches of interface, kind of like a sub-interface, is it? So we have list interface. We also have queue interface. And we will also learn set this semester, okay? So list is a sub-interface of collection, is it? And the collection, because it's an interface, so it has some method, is add something, is it? And the list, it's similar. It also has support because it's a sub-interface of collection, so definitely it's a support of the, and the plus has some more of its own methods. Is it? And for Q, it's same thing. Is it Q? Q is what? Who still remember the feature for Q? We learned in CS2 last semester. Oh, not last semester. Some of you come from the previous semester. Q.
First in, first out.
Yeah, it's first in, first out. Is it first in, first out? So it has some special thing beside the list. Is it? It's very quick at add and add at the back and retrieve from front. Is it? So that's the general architecture. Oh, I'm sorry, I just get rid of. So what over here I'm trying to do is I'm trying to following this hierarchy, following collection. I have this my list. And with my list, and then I create this my linked list. So this is still an interface. Is it? And this is concrete generic class. Okay, so how do we do this? Okay, so let's first get the my list. So for this my list, like I said, we try to follow Java framework. Is it? It's a sub interface for collection. So that's why here I said the extend collection, the extends collection. And then over here, we have the add method. And we didn't implement. So this is abstract method. Is it? And what it does, you're going to add some item at a specified index. Okay. The get method, you specify index, you're going to retrieve the content. Is it? An index of is kind of like a search. You specify item, you want to find its index. And the last index of it's you find, you give some item, you find to the last index of that item. Is it in the list? And then next, let's see, remove. And here suppose you specify the index you remove. And the set method is you try to update the contents at the specified index location. Okay, so all of those methods, add, get, index, last index, and remove and set. Is it? All of those methods, they are abstract method. Is it? Because what? Because it's not implemented here. Is it? And anyway, interface. Okay, let's recall. Interface supports 3 types of method. We just show abstract method. The abstract method is no implementation. Is it? Who still remember what the other 2 kinds of method interface can support? Okay, how about this will be our today's first quiz question. Who still remember?
Is it concrete methods?
No, we don't have the definition for concrete method. You remember static method? Is it? You can define static method. Is it? And the third type of method, default method. Okay. And both of these two implemented within interface. Is it? It's kind of contradictory, you may think, is it? Because interface supposed to just provide a framework for the method, never implement, is it? But these two are allowed to be implemented within the interface, okay? Okay, so that's the first question, okay. 3 types of methods that interface allow to support, okay. Abstract method, static method, and default method. And default method is you implement, okay. And in Java, why we have default method? So the advantage for default, because think about any software, it's not just a one time of work, is it? You are going to keep updating. Is it you have different version 1, version 2, is it like Apple 12 right now? Is it? Okay, so, but when you initially define the interface, that may be decades ago, is it? Maybe you never realize some new feature you need, is it? So the default method is pretty useful, efficient, and powerful when you have updates for your interface. Okay, so that any third party develop their products based on this specific package, they don't need to change all of their code. Is it if they implement a certain interface? Because then this interface can kind of take care of that part with some default method. Okay, so that's the design motivation for interface. Okay, then next, let's see. We have some method here. So here we also have the add method. Okay, and add method, if you take a close look, you will find it says it's override. Is it override? And its return type is Boolean. Is it? And where it add, it says it's add a new element at the end of this list. And override here, override who? Anyone can guess?
Collection interface.
Yeah, collection interface. Okay, it's override collection interface. But you see, it's implemented at the end. But over here, we can achieve this. We can implement. You call that add. And you specify, oh, at the end is the total length of your list and the item. But you may be curious, that add method defined in this my list interface is an abstract, not implemented yet. Is it why you can call it? Yes, it is allow you to call because anyway, it's based on whatever class going to implement it. Okay, how that method is defined. It doesn't matter here, is it? Here, anyway, you can still call. So let's take a look where this comes from. It call add is specify, okay, I'm going to add at the end with this item. That add method come from where? Come from the abstract method you define here. Is it? So this add method, this is a new abstract method defined in my list interface. Is it? So that's what this new method, but that add method, that is from this collection interface. Okay, collection interface. So that's why we see over here, this my list is a sub interface of collection because you have more feature you want to add. It's not, it has more flexibility, is it? Okay, so this is kind of the design idea. Okay, so we also kind of get the design idea, and basically the design pattern is a very a good topic in software engineer. Okay, in programming design. Okay, design pattern. So here it's kind of reflect part of it a little bit, kind of get the idea. Okay, anyway, so this method we now understand. Is it because it's a default method? So this is the default method. So you need to implement it. It's implemented. Is it? And same thing. The is empty method is also defined as default method. You just call the size, check if it is 0. Is it pretty straightforward? And the next, let's see. The remove method, what the document, so it's remove the first occurrence of the element from the list. Okay, then you shift all the subsequent to the left. Okay, if it's removed. So it's also a default method. You're going to remove this specific item. So how do I do that? Make it a default? Because we have that abstract method remove with specify index. And we also have this index of method. It will tell you find the item and return the index. So did you see? You completely make use of my lists abstract method here. Okay, that's how we implement this. Initially, you may think, oh, this is kind of weird, but you see it's not. And there are a lot of more default method, okay, and I didn't implement. I think it's part of your assignment, okay. So contain all, okay, and it's also default method, okay. And add all is also default method, remove all default method, retain all default method. And we also have the to array, okay. If you recall, for the list, you can convert this to an array, etc. And for an array, then it return an array of objects. The textbook leave it as exercise, but here I tried my way of implementation, okay? So what you can do is, because over here it's generic, how do we do that? You don't know what is the type of object, so you knew what, is it? We just do new object with a specified size. Is it? So the size is also abstract or abstract method of my list. Is it? So that will work. So you can call new object, but be careful, you cast it. Okay, so here we cast to make it the thing, okay? And then you just do one by one assignment, and then you return the array, okay, return the array. That's this to array. There is another to array, okay? For this to array, it's also default method, is a default method, and it has a parameter. In this to array, it doesn't have parameter, so it will just whatever your linked list item is, it will convert all the time. And for this to array, it will convert from the parameter, then convert them to the array and return, okay, and return. And here, this look weird. Is it, who still remember what does this mean? And this is a return type. Return type method. Then what this angle brackets E is here for?
Generic.
Yeah, this is the definition for what? For generic method. So this means this method is a generic method, okay? And then let's go back here. There are a couple of things you may need to pay attention, okay? And over here, this contains all. Okay, contains all. And for our my list, let's take a look. My list, it's a generic, is it? And the generic type. And the type is identified by what? By this E, is it by this E? Okay.
Could you explain the difference between default method and static method? I'm just a little bit confused.
Okay. Static method. Static method is what? It's not associated with any instance, is it? So it belongs to the class. Belong to class. So that's the difference between static method and default method. Default method, it's not so it also belongs to instance. Okay, because anyway, here we talk about in this scenario, it's regarding interface. Interface, you cannot use interface to create instance, is it? And the interface, it's always some class implements interface. If the class implements that interface, then the class is a concrete class, is it? And the concrete class then also has the static method. So if you define the static method in this interface and later on that class implement this interface, then that static method also belongs to that concrete class. So then that's class method. Okay, so it's class method. And default method, it's not a class method. Okay, instance. We don't call it instance method, is it? Because instance method is specific to concrete class, is it? But instance of that object, concrete object, can use it. It's associated with the instance. Okay, so that's regarding default method, static method. Okay, very good question. And next, let's take a look at this part. Okay, this contains more. It's still default method, is it? And over here, my list is a generic one. The generic type is E. But here, we didn't use E. We used question mark. Who remember what does question mark mean? In
Wildcard.
Yeah, it's wild card. Wild card. Is it? So what's the difference between wildcard and E? A generic method versus a method using wildcard?
We use wildcards for interfaces, right?
No, not for interface. Wildcard is not for, it has nothing to do with interface. Wildcard is for type. This means generic type. Okay. This is wildcard type. So what's the difference between these two? So over here, just think about over here. Then that means this C not limited to whatever the E type is it? Because when you do like my link list card, etc., and suppose it air equals new my link, then this air type is what? Is car. This car. So this is generic type associated with it. Is it? So it's very limited, is it, when you use it. But when you use wildcard, it's more flexible. Okay, when you define a method with wildcard, it's not just limited when you initiate with card, then later on. So then wildcard, then later on in your code, you can also support employee, not necessarily just card. Okay, so it's more flexible. Okay, so that's over here. Just pay a little bit of attention. Okay, over here it's use wildcard. This wildcard also extends E. Okay, this is wildcard. Okay. Okay, anyway, this is my list interface. Then next come to this my linked list implementation. Okay, and this my linked list. This my linked list is generic type. It implements that my list. Is it? And this time for this linked list, I have two nodes. I have a head, I also have tail, and I also have size. Okay, size. For the default constructor, nothing. I didn't do anything. Okay. And for this linked list, because the parameter is an array of objects, so over here, I just to create a list from the array of the object. So I just keep call that add method. Okay. The add method, add at where? Add at back. That add at back here. Okay, and then next, let's see. Let's go here. To see where my node definition. Here is my node definition. It's similar as what we defined before, okay? And because this time the linked list has the size instance variable, so the size method is pretty straightforward. You just return the size, okay? And then let's go back here, okay? And then for this, get to the first item. Okay, first item is pretty straightforward. If it's not an empty list, you return the head first. Okay, get last, same thing. If it's not, then you return the tail. That's the last item. And how do we do add first, add last? Is it add first, add last? I don't believe it's from the list. List we don't have add first or add last. Yeah. So, okay, so this is my linked list, the own method, okay? It's not an overridden method, okay? So add first, how do we add first? Okay, of course, you need to create an item, okay, of that node. Then you assign the first node to the newly added node, is it? And you also need to connect them. So that's the step, okay? And for tail, you also need to be careful, okay, whenever you have tail. Because if you have if you only have a single node, you need to have both head and tail point to that single node, okay? So be careful here, subtle difference. And at last, it's similar, is it? It's similar. Okay, so that's, and also at the same time, you need to update the size function, okay? And here is that add method. Is it? This add method is what? This add method, you are going to implement the add method defined in my list interface. Is it? Interface. So I implement it here. Is it? I implement. So implement the abstract method from my list interface. Okay, that's what I did. Okay, and as to how to implement, it's pretty similar as what we discussed before for insert. Okay, for the insert method for the linked list. So you need to consider 3 different scenarios that add at the beginning, add at the back, and the empty one, is it? And add at the front, at the back, and add in the middle something, is it? So similar, no new concept. And the remove first is specific for this, my linked list. And the remove last is similar. So I'm not going to go to the detail. And the remove method similar is to override the abstract method in my list interface, okay? And the similar concept as what we discussed before for remove method in linked list. And to string is also similar, okay? You just do node by node visit and do a convert to string. And the clear method, okay, so clear the list. How do we clear? You just reset everything. They reset everything. But okay, here is a question. Here is a question. Are all contents in the link? So in the my link list object cleared from memory with
No.
this? Yeah, it's not, is it? Very good, okay. But then who will take care of? Because if not, and do you have any way? Have any way to reference them after you do this?
No.
Yeah, it's also not, is it? So who will take care of those?
Garbage collector.
Yeah, it's a garbage collection. Okay, very good. Okay. Okay, that's regarding this method. And the contain method, is it? That's a contain method. So you just check if it's the item is contained. And the getter for the specified item you want to retrieve, okay? And the index of, is it? So you look for, so nothing new, is it? It's last index of set method, is it? Nothing new here, okay? And did you see, so here the point is all of those abstract methods like add, index all, last index all. Is it? Those abstract methods, they are implemented in the my linked list concrete class. Is it? Because they are implemented. Is it? That's why over here, the default method will work. Okay, that's why. Okay, so be careful about of the logic here. And then next, let's see the iterator. Is it iterator? So here we also implement the iterator, and similar we do the linked list iterator. We define this class, and this class implement that iterator, and we do the same thing has next and next. And over here we also implement the remove method. Okay, remove method for the iterator. Okay, for the iterator. We specifically implement the remove method. The remove method based on what? Based on where the current is. Is it? You are going to remove the current. Is it removed? But you are not going to break the current. Is it? It can still be looped. Okay. So so that's all for this linked list. This linked list version. Okay, implement the list, my list interface. Then let's take a look at the driver part. Okay, the driver part, we first have the string. We create a string linked list. Okay, then did you see? You just call the add method. Is it the add method? Let's see in this linked list. In this linked list, if you take a look, this linked list didn't implement that add method at all. Is it? The linked list, it's implemented where? That add method. Add method, it's implemented in the my list interface. But my list interface call add with the index. Is it? And add with the index. Add with index. It's implemented in the linked list. Okay, in the linked list. That's why this works. So over here, basically it's to call default method. Is it? Call the default method from my list interface. Yeah, you see here the logic is okay. And then you can print the list out, is it? And then you can also specify where you want to add, is it? And here, all of the country, is it? We can also call remove, is it? Call remove. And then we can check, is it? Check using the for each loop. And here, why you will be allowed to use for each loop? Because the iterable interface already taken care of that iterator method. Okay, and then over here, that's how this two array method works. Is it? That's a default method. Is it? And because it's converted to an array, so that's why over here you can also do for each loop. Is it? And here checks the contains method. And then the set method is a set method. Nothing new here. And here we display the iterator. Okay, the linked list using iterator. So you get the iterator. Get the iterator, and here we say, okay, we try to remove United States from the linked list. How do we do that? Is it for this loop? Okay. For this loop, it says, okay, it can do the has next. And if you use for each loop, you cannot achieve this goal. Okay. But with this iterator, then if you find it, then you can call the remove method. Is it? You can call remove method. And otherwise, if you didn't find it, then you just output whatever that item is it? And over here, it can check if the item is removed. Is it is removed? Okay. And here you clear that list and then you check the list. Okay, the size. So that's all of this driver part. Okay, so let's see what we add. We add America, Canada, Russia, France, Germany, Norway, Poland. Then we also set the second item. Is it to United States? Where do we get it? Where did I set the to? Oh yeah, we update is it its content as United States, and then here we try to do the remove. Is this using iterator? Okay, so let's run this program. So we run this program, is it? So over here, I believe it's all regarding you keep adding one by one, is it? So it does work, and then call the linked list to string method, the to string method. Let's see where that America's index. America's index. Okay, so over here, that America's index, and then America index, and then not this, not the car one. And then we said, okay, display the linked list using iterator. They're using iterator. And using iterator over here, it's just try to see if it can find it. Is it? If it find it's going to remove. Otherwise, it's just output. Is it just output? Okay, so over here we have this Canada, then United States, and Russia, and then France. Is it? And display the linked list using iterator. Is it? So here, did you see that United States is removed? Is it? After you remove, it is removed. But here, be careful, okay? United States supposed to be here. Is it supposed to be here? United States. The second item, is it? And generally, you see, if you use definite loop, then you should loop 4 times. Is it 4 times? Is it? Then if you do the remove, basically you decrease your list size by 1. Is it? Then it will break your loop. Okay. But you see, with you use the iterator, it won't. You don't need to worry this definite number of iteration time. It can keep going. Is it? So it still do the next and do the next. Okay. So that's the usage for the iterator. Is why it also supports remove. Is it? Because once it supports, then you can do, you know, it internally it will adjust. Is it? It will adjust the iteration. Okay, so that you don't need to worry about that. It won't, but if you use for each loop, then this won't work. Okay, so that's the whole point here. Okay, so so basically we complete discussing about simple linked data structure. Okay, linked data structure. And what next? Let's get to our course website. Just print. The course website, so we finish this part, is it? And all the class examples is accessible under class notes, okay? So I have all of the example listed here, and you can refer them. And the slides, I didn't follow the textbook slides, okay? But if you want, you can refer it. Okay, so that's